Bienvenidos, Ushamadid, and welcome UMGC learners for the CMIT-455 Section 6380 course in the spring 2021 semester. This is the CCNP ENCOR version 8 curriculum from the Cisco Networking Academy, and what we're doing in this supplemental tutorial video is we're wrapping up our discussion about virtual routing and forwarding, specifically VRF-Lite. Now, you might be looking at the title on the slide and asking yourself, why does it say Easy Virtual Network when in fact we're talking about VRF-Lite? Now, VRF-Lite goes by another name as well, called multi-VRF, or you might see it as multi-CE VRF or multi-VRF CE, right? There's many different names depending on the context in which we're discussing VRF-Lite. Now, Easy Virtual Network is nothing more than sort of a new way to do VRF-Lite configuration. Now, there are some bells and whistles and some advantages to VRF-Lite, which I'll talk about when we start to discuss use case when we get into the configuration. But for right now, to answer the question, what is Easy Virtual Network? I like to refer to it as sort of the macro version of configuring VRF-Lite. In other words, a macro is simply a command that you would run that behind the scenes is running several other commands. For example, if I was to come on to switch 1 here, and let's go from user exec mode into privilege exec mode, and let's take a look at the interface fast Ethernet 01. So I say show run int fast Ethernet 01, and you can see that there's no configuration on that port. So I would go into global config, go into the interface fast Ethernet 01, and it's from here where I can use a macro. So if I say switch port, you can see that I can say switch port access and put the VLAN in there. I can say switch port security. I could say all kinds of different things, but it's this host macro option here. And what I mean by macro is watch what happens when I say switch port host. It's actually running a number of commands. It's doing a number of things behind the scenes that would require me to use multiple or to enter multiple configuration commands. So now let's take a look at the port do show run interface fast Ethernet 01, and what are some of the things that happened here? Well, it made the port, it hard-coded it as an access port with the switch port mode access command. It enabled the spanning tree port fast command so that I didn't have to come in here and say spanning tree port fast. I'm sorry, not port priority. We want port fast altogether. Spanning tree port fast. And so I didn't have to enter that. So it actually applied multiple configuration commands as the result of me using a single command, which is switch port host. And so I refer to that as a macro. And that is, in a large sense, what Easy Virtual Network is all about. Now, let's take a look at our diagram here, and let's see where we're going to be applying EVN, Easy Virtual Network. And you might be asking, well, wait a second, that's not what you did on router 3. Over here, you manually did the configuration for this sub interface, and for the GRE tunnels, you had to go into every tunnel interface and say VRF forwarding. And then for the tunnels, we said tunnel VRF, right? Remember that. The difference between that VRF forwarding command is that puts the interface into that VRF's rib. When I say tunnel VRF, that's what tells the tunnel which VRF is going to be used for its source and destination statements, for that tunnel source and tunnel destination. But again, we start back here at router 1. I had to go into every interface here, VRF forwarding, and then put the IP address and create the VRF. Same thing on router 2. When we got into the sub-interface configuration here, basically a trunk link between these two, I had to go in and I had to say VRF forwarding for the sub-interface, encapsulation.1q, whatever the VLAN number was going to be, or I should say that tag, the 802.1q tag that we were using. And you remember, I had to do everything manually all along the path here. And so now you're going to see what Easy Virtual Network can do from a configuration perspective to sort of macroize, if you will, that configuration work. Now, do we have to create the VRFs individually? Yes, we do. But it's after that point where we're going to have some auto magic things happen in terms of the sub-interface configurations, right? Or I should probably be over here, either on the frame relay side or on the 802.1q trunk side here. The sub-interfaces are auto-magically going to be configured for me. The VRF forwarding statement, you're going to notice that kind of disappears. Now it's hidden and we're going to find it with a specific command, and we'll take a look at some other commands. But for right now, EVN is not something that is proprietary. In other words, if router 3 was a Juniper router, I could still run EVN on router 13 in terms of this configuration component here for the .1q trunking, again, a standard, and really all EVN is doing from the configuration perspective is it's allowing me to enter in sort of staging commands that will then be used behind the scenes to create this .1q trunk, and then it's going to work with this legacy configuration that we've configured over here on router 3. Now, I've already done the configuration on router 3 to save us time so that we can focus on the EVN config. So not only do they work together, but if I was to migrate router 3 to an EVN configuration, I could do that as well. Now, EVN is not a protocol, right? It is simply, you could even think of it as a wrapper in terms of configuration syntax. Now, it gives us a couple additional commands. Yes, it's going to make the replication of routing information, or I should say the leaking of routing information between the VRFs. It simplifies that and it removes having to use Ebgp to make that happen. And so that's one of the significant advantages. But again, let's dive into the command line and let's see how exactly we would configure this. Again, enough talking about it. Let's take a look on router 13, which is the router that we're going to be using. So let's go from user exec to privilege exec. Let me say show VRF. Do we have any VRFs configured? We don't. What about show IP interface brief? Any IP addressing? We're going to be using gig 01, which is why it is in the up state right now. But as you can see, I've got no subinterfaces, no IP addressing, no VRFs, and no routing protocol, right? So nothing's working. Now, again, we're going to be doing loopback interfaces, which we will also be using that VRF forwarding statement for, because again, those aren't the trunking interface here, or that .1q interface that's going to be running between routers 3 and 13. So how do we do easy, or I should say, easy VPN. How do we do EVN, Easy Virtual Network? Well, we come in here, we go into global config. Remember, I said we still need to define the VRF. So I'm going to say VRF definition red, and I'm going to go ahead, and if I do a question mark right here, you can see VNet is an option, virtual networking configuration. So I'm going to say VNet. If I do a question mark, we put a tag, and that is really staging the 802.1q tag, that incap.1q command. What I'm doing here is I'm seeding this VRF with the tag right now. So I'm going to put the tag here. That way, on the sub interfaces that will be configured for us, I don't need to go into those sub interfaces. and put this command. So for the red VRF, the VNet tag is going to be 10 because, again, this is where, if I was using sort of the legacy configuration approach with VRF definition red, address family IPv4, and then I would have to go into interface gigabit Ethernet 01.10, VRF forwarding red, incap.1q 10. And so that is the statement right there. I say VNet tag 10. Again, if I was to do the address family IPv4, and I think I need to bail, I don't need to bail out. So I say address family IPv4 if I wanted to do address family for IPv6, right? That's all I'd have to do. So let's do both v4 and v6. That's the difference right there, right? Is I simply kind of stage that little VNet tag 10 in there. Other than that, everything else that we've done is the same. So VRF definition blue, VNet tag 20. Again, seeding that incap.1q information for sub interfaces, it's there right now. Address family IPv4 and then address family for IPv6. VRF definition green. VNet tag 30. And then address family for IPv4, address family for IPv6. So let's go ahead and say end. Let's save our config here just in case. And now let's go ahead and let's say show VRF. All right, so here are the VRFs, right? Remember, I created the blue, the green, and the red VRF. We've got the protocols, no interfaces involved yet. Now, you'll notice route distinguisher. Easy Virtual Network, EVN, does not require a route distinguisher because, remember, it's just sort of VRF-Lite or multi-VRF. And if I'm saying multi-VRF, you're typically implying multi-VRF for CEs or multi-CE VRF, right? And so that would sort of imply MPLS. Again, EVN is not, it can be used in an MPLS scenario, but as we're using it here, it's just VRF-Lite. Again, the difference is I've added that command in, and let's see now what that command is going to buy me. So let's go into global config. Let's go into interface, what did I say? Gigabit Ethernet 01. And here's what we're going to do. Remember, do show IP, and you'll see what's going to happen here. IP interface brief. And you'll see there's no sub-interfaces, no configuration there. All I say here is VNet, and I'm going to pull the command up for you here in the context-sensitive help. I'm going to say VNet trunk, and unfortunately it's way down here at the bottom. And there's the command. Configure VNet interface options. So I'm simply going to say VNet trunk, and if I do a question mark, I can do a list, right? And I could, I could do a list, and I could limit the VRFs that are allowed across the trunk. We're going to allow everything right now just to keep it simple. But again, that's the command. So instead of coming to each of the sub interfaces and having to enter in the information for each of the sub interfaces, when I say VNet trunk, this, and again, you can think of this as the macro command here, right? What is that command actually doing behind the scenes? So I say VNet trunk, and let me say do show IP interface brief now. Well, look at this. I say VNet trunk, and what did it do? VNet trunk looked at the VRF configuration and looked at the VRFs that had VNet tags defined and said for each VRF where VNet tag is defined, int gig01.vnet tag, int gig01.vnet tag for 20, .vnet tag for 30. And so what that wrapper, this macro command does is it looks back at the VRFs that are defined and then says for each of those VRFs where a VNet tag has been defined, create a sub interface. Now, here's the beauty of doing this one time. And again, this is where that conversation of use case comes into play. So if you're just doing vanilla VRF-Lite and you need to provide segmentation at layer 3, you're not going to be doing route leaking between the VRFs, or you don't have a need for some kind of central services, something like that, then, you know, a couple of VRFs and you've got to go through and do the, you know, because I got to create the VRFs anyway, right? I still have to create each VRF. But again, if you're spanning 5 or 6 routers, then maybe that's not that big of a deal to go in there and create each of the sub-interfaces. And again, when you use EVN, it doesn't mean that you have to do route leaking or route leaking between VRFs. It doesn't mean that you're doing multi-VRF CE, right? It doesn't mean those things. So it's going to be up to you what is easiest for you from the configuration perspective. Because again, it kind of comes down, if you think about when we talked about the VLAN trunking protocol. Yeah, if I've got 3 switches, it's not that big of a deal to put those into transparent mode and maybe configure the 4 VLANs that I'm going to be using on each of those switches individually. Now, if I've got 50 switches and those VLANs are end-to-end and spanning all 50 of those switches, and I've got, 60 VLANs I need to create, then maybe I should be having a conversation with myself about whether or not VTP would be of use, and specifically VTP v3 would be something I would want to investigate, right? Again, it's all about use case. So back to this conversation. VNet trunk on the parent interface, the physical gig01 interface, is a wrapper. It created those auto-magically for me. So let me say do show run int, and let's see what exactly is under gig01.10. Yeah, where is my encap.1q10 command? What about, well, maybe it's over here. Maybe I've got the encap.1q statement here. No. What about here? Again, no. It's not there, or at least you can't see it. And there's a difference, right? So this is one of, again, the sort of the marketing magic behind the catchphrase EVN, Easy Virtual Network, and it's automating these things for us. What if I say do show derived config? So if I say do show derived config, which is another command, let's get all the way down here. I probably should have limited it out to the interface. But now, when I say show the derived config, what do you see? Yeah, there it is. There's my VRF forwarding red statement. And we know that this is on the correct subinterface because that's the interface we put the VNet tag 10 on. And it even dropped a description in here for me. So in the derived configuration, which is different from the running configuration, what do we see? We see all the VRF commands on the sub interfaces when I say VRF commands, I'm talking about those commands that we would have to put on here to get these sub interfaces up and ready and working with the VRFs that we've created. And so hopefully you're seeing what EVN really is. It's kind of a macro wrapper. It makes the configuration of VRF-Lite or multi-VRF, if you will. It makes that easier. Again, VRF-Lite, we're not talking about the MPLS context because we're not doing route distinguishers. And multi-protocol BGP with MPLS, right? So again, in our scenario, we're talking about VRF-Lite, not multi-VRF or multi-CE VRF or multi-VRF CE. You hear it a million different ways. And so here's the configuration. So what don't we have on the sub interfaces right now? Yeah, we're missing the address, but remember, I wouldn't put the address on, because I'm not creating the sub interfaces, so I wouldn't go into those and put the address. And again, It makes it really simple. EVN makes it really easy. So watch what happens now. I'm going to say IP address, and we're going to use 169.254. Remember, this is just simply a transit segment between router 3 and router 13. And so we'll use the higher router number here, obviously, for the third octet, along with the lower router number following it. And this is router 13. And so we'll say, make it a /24. And you might be wondering, wait, whoa. You have to go into the sub interfaces to do that, right? Not with Easy Virtual Network. Watch how easy, I'm doing my air quotes, watch how easy it is to do this. Because again, we've got the statement on that interface. Let's look at the do show run int gig 01 interface. What is on there right now? I have the VNet trunk statement, meaning that for the sub interfaces that I'm using EVN on that have just been created, do what? You guessed it. Put that same interface IP address on every sub interface. Because remember, what routing context is that interface in? The parent interface is in the global routing context. How can I prove that? Do show IP route. There it is. That is the parent interface. It's in the global routing context. And so when we first started doing sub-interface work here between router 2 and router 8, you might have been thinking, he's crazy using the same IP. You would never do that. Well, now let's fast forward to the conversation about Easy Virtual Network and what exactly is it doing, right? So the reason I did that early on was knowing that we were going to get here to have this conversation to show you what do the wizards of smart at Cisco do with Easy Virtual Network. They do exactly what I showed you how to do manually with VRF-Lite. Instead of having to come up with, I'm going to come up with like 5 different subnets that I'm going to use for each, one subnet per sub interface. No, stop right there. You wouldn't do that. You don't need to do that. And here is Cisco showing you that with their super new approach to VRF-Lite or multi-VRF, right? I'm going to keep throwing that in there, right? Transition to the MPLS conversation. Look at how they do it. They're doing it exactly like I was doing it manually. They're using the exact same IP address on every sub interface, including the parent interface. Now, I didn't IP address the parent interface. I could have, but I didn't, right? Because we weren't doing anything with the global routing table. But here, EVN does that for you. So you put the VNet trunk statement on the parent interface, and auto-magically, all your sub-interfaces are configured. They're configured with a VRF forwarding statement. They're configured with your incap.1q statement. They're even given a nice little comment. That's the macro-esque behavior of the VNet trunk command. And then I come in here and I put the IP address on. And the VNet trunk command auto-magically throws that IP address that we put on the physical interface, the parent interface, which is in the global routing context. It gets that IP address and subnet mask, and so do all of my sub interfaces. That's the easy way to do it, right? And again, if you only had 2 VRFs that you were using with VRF-Lite, maybe you do EVN, maybe you don't, right? Again, it's all about the use case and what you're comfortable with doing. But I'm here showing you that if you had like 5 or 6 VRFs and you're doing this between trunk interfaces, .1q tagged interfaces between the routers, EVN is probably going to be the way to go. So now we've got that sorted out. You might be asking yourself, well, hold on, what about do show IP interface brief? What about all those loopback addresses that we need to configure? They're not here. So do I have to say VNet trunk on those? Well, no. Let's go ahead and do that. Interface loopback, and let me double check here. I think I'm 1, 2, 3. Yep. So interface loopback 1, I would simply use my VRF forwarding statement, right? VRF forwarding read IP address 13, 13, 13, 13. We'll make it all 255s. I'm going to go into interface loopback 2, VRF forwarding blue, and we're going to recall that IP address. We're going to go into interface loopback 3 because I don't need the .1Q tagging on the loopback interface. So I'll just use the VRF forwarding statement. Again, you can use the legacy VRF-Lite configuration approach like we've done on all the sub-interfaces up to this point, and then on this side, I can still do EVN because what exactly is it doing? It's doing the exact same thing from a configuration standpoint that I did with the legacy configuration. It's just sort of automating pieces of that config. So interface loopback 3, VRF forwarding green, hit the up arrow a few times, and there's my IP address. So let's say do show IP interface brief. So there they are, and they're in the right VRF. So do show VRF, let's see what we see. And take a look what do show VRF shows me. It shows me the sub-interfaces that are in there along with the loopback interfaces for each of the VRFs. What if I say do show VNet? Now this is an interesting one, right? Because it's going to look exactly like that output, except the default route distinguisher, because we're not using route distinguishers in the VRFs, it just says not set. What is it replaced with here? Let me hold the, wrong, it's always the option key. What is the default route distinguisher replaced with? It's replaced with the VNet tag information. And again, this shows me the VRF name. And again, does it not look identical, right? And maybe, you can argue, oh, well, the IPv4, there's no comma IPv6. It's just listed as a new column here. But you get the idea. This is how I can see the EVN VNet configuration. Now, one of the questions I get asked a lot is, okay, well, what happens when you add a new VRF? So what if I was to say VRF definition, and let's use a new color, we'll just say purple. VRF definition purple. Well, remember, what if I say VNet tag 99? Maybe purple is going to be my management VRF, right? So VRF definition purple VNet tag 99, address family IPv4, address family IPv6. Let's say do show VRF. Now, no interfaces in VRF purple, and you can see it's listing these out alphabetically here. No interfaces in VRF purple, not a problem. What about do show VNet? What is that going to show me? Well, it's going to show me that automagically a sub-interface was created on gig 01 where the VNet trunk command is already applied on that parent interface. So let's say do show derived config, and let's see if I come down here a little bit further. And of course we fly right by it. But if I come down here a little bit further, let's look at all of the sub interfaces. So I create a new VRF, and what does it do for me? Right out of the gate. Boom, there it is. I don't have to go into the sub interface. I don't have to put a description on that sub interface. I don't have to say incap.1q99. I don't have to say VRF forwarding purple, and then I don't have to put an IP address on it. So again, it makes it so easy when you're doing multiple sub interfaces with multiple VRFs. Easy virtual network is definitely the way to go. So let's go ahead now, and what do we need to check? Well, let's take a look at router 3, and you can see that router 3, because of some of the work we've been doing, has its interface up. Let's say show IP interface brief here with router 3. And as I said, I already configured the sub-interfaces. We've done this manually enough times, so let's test. Let's see, does the legacy VRF-Lite configuration, will I be able to ping the other side? Remember, EVN is not a protocol, right? It's not as if there's some protocol running between the switches here. As I showed you, it's like a wrapper. Yes, there's a change in the ICMP packets because we can do sort of an enhanced tracing thing when we go into the routing context for a VRF, and I'll show you how to do that with EVN. Again, there's some enhancements, right? And it's really nice, but don't think of it as like, oh my God, EVN, it's like this totally new protocol and it's doing all these insane things. No, it's a macro basically on the configuration side. And sure, there's some other things that are happening, but again, they're all kind of from a macro perspective. So ping VRF red 169.254 133.13. So do I have connectivity in the red VRF? Check it out. Beautiful, right? Ping VRF blue. Ping VRF blue. And we're going to do, where's that IP at? There it is. Okay. 169.254.133.13. And probably on ARP. And then we've got connectivity. And then finally, let's say ping VRF green 169.254.133.13. And we'll see we've got connectivity. Everything is working beautifully. It's just that it was way easier to configure. All right, so now what is it we need to do? Well, let's say show run section router OSPF here, because again, we want to bring OSPF up. I've already placed the network statements here and took it upon myself to make sure that the sub interface has the no passive interface on there. So let's go over to router 13 and let's do OSPF config just like we normally would do. So router OSPF 1 VRF red, we're going to say router ID 0.0.0.13. We're going to say passive interface default. We're going to say no passive interface gigabit Ethernet 01.10. The same sub interface, right? And then we're going to say, I just lost my train of thought. Yeah, we're going to go ahead and put our network statements in here for the loopback address that we're using. And we'll put this in area 0. And then we'll drop in the network statement for the transit sub interface. 169.254.133.13 with the quad zeros and area 0. And after I hit enter here, what we should see is an OSPF adjacency come up. Boom. And that's it. So let's do it again. Router OSPF 2 VRF blue. We're going to say passive interface default. We're going to put the router ID actually. 0.0.0. Now here's where we might run into an issue. So I'm going to say 13.13. So blue is just going to have 13 twice. And then we're going to say, I'll pull that network statement back up for the loopback address. And then we'll go find that network statement for the sub interface because they've all got the same IP. Again, making it even easier. No passive interface gig 01.20. And within a few seconds, we've got an OSPF adjacency. And then finally, let's say router OSPF 3 VRF green. We'll say passive interface default. And here we'll say router ID 0.13.13.13. So we'll just put 3 13s in there. We'll say no passive interface gigabit Ethernet 01.30. 1.30. And then we'll go find those network statements to save us a little bit of typing. We'll get the transit segment, the loopback address, and let me go ahead and save this configuration here. And we are now running EVN on router, I mean, we're running it before, but we're running EVN on router 13. That's how we did the configuration work. And now we've got OSPF running across those sub interfaces. If I say show IP route VRF red, do I see the OSPF information from all across the routing domain? And take a look at that. I do. So let me test from router 13. Can I ping VRF red? And you'll notice I'm using the old VRF-Lite commands here, right? Or sort of those legacy, I'll call them, VRF-Lite commands, even though I've used EVN to do the configuration. So ping VRF red, can I get to the network simulated with a loopback behind router 1, all the way on the other side of the network? Sure. Can I do the same thing with VRF green? Or let's do blue. We'll do it in order here. To the 10.2.2.1. I've got connectivity. What about to VRF green? And the 10.3.3.1. And it's working, right? We've got it up. We've got it working. So now let's talk about a quick enhancement here that you might see. And this is, again, one of the nice things with EVN. Since I have EVN configured here on router 13, I've got access to the command routing context. And what I can do is, and you'll see, I can, and this is from privilege exec, I can say routing context VRF, and I can move into one of these VRFs. Now look at how EVN treats the global routing context. It gives it the name global, so I could go into the global context, but we're going to go into red. So routing context VRF red. And you'll notice that the prompt has changed because I'm now sort of magically inside the red VRF. So instead of saying ping VRF red to the 10.1.1. Sorry about that, 1.1, again, the command still works, but what if I was just to say ping 10.1.1.1? Because the router knows that I'm in the red VRF context. So I could move into the VRF context. What if I say trace route over to the 10.1.1.1 and source it from my loopback 1 address? Again, I don't have to say VRF red. Excuse me. Now, once I'm in the context, how do I get out of the context? Well, what if I type exit? And it works like a champ, right? So if you were doing a lot of work, maybe troubleshooting in a specific VRF, and you'd used EVN to complete your configuration, you could just dive into that VRF. Now, one of the things that EVN also does is it will provide the VRF name and the VNet tag over trunk links. Again, we're not seeing that information here because I'm not doing EVN on the other side. And I want to leave you with this. So Ivan Pepeljack is an amazing author. And this blog, if you're not following this blog or checking this blog every so now and then, there's a ton of information here. It's just blog.ipspace.net. And he has an amazing blog post here on Easy Virtual Network. And you can see he says the same thing that I'm saying, is that it's nothing new under the sun, right? EVN, sure, it gives you some new functionality, but really it's just a wrapper for the configuration component of VRF-Lite or multi-VRF. And this is an amazing write-up that he's got here. And what I love about it is he points you to the EVN white paper or the IOSXE configuration guide or the question and answer document. And in fact, if I was to pull up the white paper here on Easy Virtual Network, this is a very easy and a very, very good read. And this is going to give you all the information you need to know about EVN. And it's got some really nice images here that sort of break down what is happening when you're using EVN. All right. Well, I hope you enjoyed this 5-part series where we kind of tackled VRF-Lite and we looked at a number of different use cases. We looked at dedicated physical links. We looked at 802.1q trunk sub interfaces running between two routers. We looked at back-to-back frame relay, where we created frame relay point-to-point sub interfaces on a single physical serial link. And then we created GRE tunnels. And over those GRE tunnels, we continued to extend the VRF's reachability. And then finally, we ended up, after doing all of that sort of manual configuration all that time, all the way through, we said, wait a second, Easy Virtual Network is a much simpler way to do it. And we saw that it's really kind of a macro from the configuration perspective. Yes, you can do route replication or route leaking into VRFs a little bit easily. But it saves us a ton of work up front. Remember, EVN is not a replacement, even though in that white paper, I think at the bottom, it states that EVN is an alternative to MPLS. I would argue with that statement that it's not. And I agree with Ivan in his blog post that this is not an MPLS replacement. You would not, because and I forgot to mention this as I'm saying that, the limit to the number of VRFs that you can have with EVN is 32. So that is not, from a service provider's perspective, that's probably not what they're going to go with. I mean, that is a huge limitation right out of the gate if you're talking about, oh, I've got thousands of customers and we're going to have thousands of VPNs. EVN is probably not what you're going to be using to facilitate that in your backbone network, right? So it's not a protocol, and it is multi-vendor, because how is it working? What is it that we're doing? We're still doing 802.1q tagging, trunking between the routers. So if I had a Cisco router and I've got EVN configured, if the Juniper router that's connected up with me is using their version of VRF-Lite, right? If they're just creating a bunch of sub-interfaces and using VRF to carve that up, then we're going to work great as long as our tags are in sync. And that is what Easy Virtual Network is all about. All right. Well, thank you guys so much for watching. Let's move on now to BGP, the Border Gateway Protocol, and specifically, we're going to be taking a look at eBGP. All right. Thanks for watching, and I hope to see you in the next video.